The objectives for today. Choose and produce an equivalent form of an expression to reveal and explain properties of the quantity represented by the expression. Factor a quadratic expression to reveal the zeros of the function it defines. And we have done this. But now we are going to complete the square in a quadratic expression to reveal the maximum or minimum value of the function it defines. And today what you're doing is completing the square in a quadratic expression only. Practicing that, and then this comes later on. So here is the opening exercise. And it says to rewrite the following perfect square quadratic expressions, which are these, in standard form. Look for patterns in the coefficients, and we will do that together. You don't have to write sentences for that. This is the form we start with. We're going to write the factors out. We're going to multiply them and then arrive back at the standard form when it's all written out. So here's the first one that I'll do for you. The quantity squared of x plus 1. If I want to write the factors for that, then I would write x plus 1, x plus 1. When you square something, you multiply it by itself. Then, when I multiply it out, you must remember back to how to do that. X times x, x times 1, 1 times x, 1 times 1. And then add your like terms. You have two x's in there, so x squared plus 2x plus 1. For x plus 2, the quantity squared of x plus 2, what do I write first? And then x plus 2. When I multiply it out, what do I come up with? X times x, x squared, x times 2, plus 2x, 2 times x. What's 2 times x? Plus 2x, and then 2 times 2, 4. When I combine my middle terms together, what do I come up with? What's my new standard form? What do I write first? X squared plus 4x plus 4. Yeah. Add your middle terms together to get 4x. Quantity squared of x plus 3. I want to write the factors out. What are the factors? X plus 3. X plus 3. When I multiply them out, what do I come up with? X squared plus 3x plus 3x 3 times 3, 3 times 3, 9. When I simplify, what do I come up with? X squared plus 6x plus 9. Quantity squared of x plus 4. I want to write the factors out first. What do I write? X plus 4, x plus 4, When I multiply it out, what do I come up with? X squared plus 4x plus 4x 16. Yes, 4 times 4 is 16. When I simplify, what do I come up with? That's right, 8x, or x squared plus 8x plus 16. All right, back to this one. Quantity squared of x plus 5. Write the factors. What do I come up with? X plus 5. X plus 5. When I multiply those two together, what do I come up with? X squared plus 5x plus 5x plus 25. That's right. And when I simplify it, what do I come up with? X squared plus 10x plus 25. Right. Okay, down here at the bottom of the table, notice that it skips to 20. We went 1, 2, 3, 4, 5, but now we're at 20. What are the factors? X plus 20 and x plus 20. When I multiply those two together, what do I come up with?
X squared plus 20x plus 20x plus 400.
That's right, x squared plus 20x plus 20x plus 400. When I simplify, what do I get? X squared plus 40x plus 400. That's right. The patterns you should look for. You can look for patterns in here, or from here to there. Somebody tell me a pattern that they notice in this. Yeah. There's an x squared in all of them? Yes. What's another pattern? Yes, 1, 2, 3, 4, and 5. And then we went to 20. But we knew how to do this because we had done these. Do you notice a pattern from this column over to this column? What about this 3? Let's just pick this 3 out. What happens from here? How do we derive any of this stuff over here from this 3? You're squaring the 3 to get 9. We square the 2 to get 4. Square the 4 to get 16. Square the 5 to get 25. But what about this? What about these middle terms through here? How are we getting these from these numbers through here? Times by 2. Yeah, so if we double this, it gives us the 8. And it's going to be an 8x. Double the 5, get a 10x, and so on. Double the 20, get a 40x. So with those patterns, we should be able to reverse those patterns and go backwards. We'll go backwards down here in this. So we're going to start with the standard form and try to take it all the way back to the factored form. I'm going to change my marker to a different shade of blue. There we go. Alright, so here's my factored form, the quantity squared of. But what's the first thing I put in the parentheses? X. And then how do we know to put a plus sign? That sign there is what's going to go in. So it's plus. How do we know how to find the last term in there? Divide 12 by 2 to come up with 6. There it is. Let's try that with this one. What do I write first? X, what's the sign? Minus, and how do I know what's next? $12 divided by 2 is 6. You can check these. Is 6 squared 36? Is 6 squared 36? Yes. So what about the next one? I write x, and what's the sign? Plus, then what? 10. 10 is half of 20. Check that. Is 10 squared 100? Yes. All right, what about this one? X, what's the sign? Minus. And what's half of 3? Half of 3 is what? 1.5. Okay, we can put 1.5, but we have to check 1.5. Is 1.5 squared the same as 9 divided by 4? It is? Yep, so it works out. All right, try this next one. Quantity squared of x, and what's the sign? Then what? What do we do to find it? Divide 100 by 2, and it is what? 50. Is 50 squared 2,500? Yes, so it works out. All right, here's another one. Quantity squared of x, what's the sign? Plus. Now what? 4. Okay, let's check this. Is 4 squared 3? No, so it does not work out. We've done all of this to arrive at this example. And here's an example of one that does not work out, but you can rewrite it using a perfect square factored form binomial. And whenever you run into this, here is what you're going to have to do coming up next. On the last page, we ran into this one that did not work out to be an equivalent expression. So what we want to do is find an expression equivalent to 8x or to x squared plus 8x plus 3 that includes a perfect square binomial. We're going to rewrite this into a new expression that includes a quantity squared of some binomial, and then it may have some terms outside of the parentheses. Here is how you do it. First, you want to isolate these first two terms. X squared plus 8x. And from that, you want to generate the third term in there that would make that quantity a perfect square. Do you remember how to get to that last term? What do we do to find that last term? What do we do to any one of these numbers? Well, what do we square? Remember the pattern in the other ones? We squared a number to get to the last number, but how did we come up with that? Here's an example. Before we had something like x plus 2, we did this one, and we came out with x squared plus 4x plus 4. How did we come up with this number to come from this? We didn't square it. Multiplied it by 2, right. So what did we do to this? We squared this number to get that. But in here, all we have is this part of it in this challenge problem that we're doing now. How do I find this number so I know to square it? How do I get it from this? Divide by 2, right. So what is 8 divided by 2? And what is 4 squared? 16. There it is. But remember, this has to be an equivalent expression. So if I add 16 to this expression, inside the parentheses, what do I have to do outside the parentheses to make sure it all stays balanced? I've added 16, but I want to make sure I bring it back down to 0 outside of it. What do I do outside the parentheses? If I add 16 inside of it, I've now increased the value of the expression by 16, which means it's no longer equivalent. If I want to bring it back down to where it is equivalent, then what operation must I do outside of it? I have to subtract 16. Here is the expression as it is on its own. We've added 16 to it here, thereby changing the value of the whole expression. It's no longer equivalent. In order to make it balanced again, you must take 16 away on the outside. That means essentially we've added 0 to this expression and not changed its value at all. You can see that illustrated over here on the right. What if I started off with a 5 and I added 7 to it? Do I have a 5 now? What do I have? 12. If I take 7 away, am I back at 5? If I add 7 and take away 7, am I still going to be at 5? Yes, so that's what we're doing over here. If I add 16 and then subtract 16, I'm still going to be at this same value of expression. The only thing left to do with this is to write it in a perfect square form. I would have x and then what sign? What sign is this? Plus. And what number do I put in here? Where do I get that number from? Remember when we worked backwards? Do you remember how we came up with this number here? We had to square that one. And in order to get that number, we had to do what to this? Divide by 2. So down here, half of 8 is 4. On the outside, you have 3 minus 16. What is 3 minus 16? Negative 13. Here is your answer. The quantity squared of x plus 4, close the quantity, minus 13. Let's try number 1. And I must isolate these two so that I have a squared minus 4a, leave a space, and then plus 15. How do I find what goes in this space? What do I do first? What is 4 divided by 2? 2. What is 2 squared? 4. If I add 4 inside the parentheses, then what do I do on the outside? Subtract 4. Now we want to write this as a perfect square. So the quantity squared of a, and what's the sign? Minus. What do I do to find that missing item here? Divide 4 by 2 to get 2. On the outside, I have 15 minus 4. What's that? 11. So we have plus 11.
Teacher, please excuse the interruption.
Isolate these two and come up with n squared minus 2n, leave a space, close the parentheses, and then minus 15. What do I need to do to find this item that goes in the blank space? What do I do first? Divide what? Divide this 2 by what? 2, and 2 divided by 2 is what? 1. What's 1 squared? 1 squared is what? 1. So plus 1. If I add 1 inside the parentheses, I have to do what outside of it? Subtract. We must now write this as a perfect square. N, what's the sign? minus, and then how do I find the number that goes in this spot? Divide 2 by 2 to get 1. And then on the outside we have minus 15 minus 1, which is what? Minus 16. There's your answer. To write an equivalent expression with a perfect square binomial in it, you must isolate these two and come up with c squared plus 20c, leave a space, and then minus 40. Half of 20 is 10. Square that to come up with 100. If I add 100 there, I must subtract 100 out here. And then write it in the proper form. C plus half of 20 is 10. Out here you have minus 40 minus 100. It is minus 140. Let's isolate these two and come up with x squared minus 1000x. Leave a space, and then you have plus 60,000 out here. Half of 1000 is how much? 500. 500 squared is 250,000. And if I add 250,000 in there, then I must subtract it out here. Write the proper form. Quantity squared of x minus half of 1000 is 500. Close the quantity, put the square symbol on it. And then 60,000 minus 250,000 is minus 190,000. Isolate these two terms and come up with k squared plus 7k, leave a space, and then plus 6. What do I do to find this middle term here? Divide 7 by 2. Now you can come up with a decimal if you want to. You can also leave it as just 7 over 2. And if you square 7 over 2, you come up with 49 over 4. Same thing. And if I add 49 over 4 in the parentheses, I have to subtract it outside. So write the proper form, quantity squared of k, and then plus, from here, half of 7 is 7 over 2. Close the quantity, put the square symbol. And then you have 6 over 1 minus 49 over 4. That's middle school math. You should be able to subtract fractions. When you do that, you're going to come back with minus 25 over 4. Let's do that same problem again. K squared plus 7k plus 6. Can you remember back to when we factored a different way, where we did this, two quantities, a k in each one of them, and if the signs in the expression were plus plus, they were what in the parentheses? Plus plus. So plus plus. And can you give me two numbers that multiply to get 6 and add to get 7? 1 and 6. There it is. Another way to factor the exact same expression. On your homework, you have 6 problems to do that are just like the ones we did here in class. You must write the problem, you must show all of the work, and then show the answer. If you do that, you get your points. And we'll take care of right and wrong, which in fact you can find on Facebook tonight. But if you don't have the work, you don't get any points. Number 7, which of these expressions would most easily be rewritten by factoring, like what we just did with that last example, where I showed you or reminded you the other way that we've done it before? Notice that it says justify your answer. So you must answer with more than just a problem number. If you say problem 2 as your answer for 7, it's not going to count. You must use complete sentences, whatever mathematical stuff you need, but it must look like a complete answer, answered thoroughly.